Hello, Mr. Burrell here. We're in Unit 8 here. We're talking about logarithms and exponential functions. We've talked about graphing these. We've talked about transformations of these types of functions. We've talked about how to find the asymptotes, the domain and range. We've talked about all those different things. Now we're going to delve into evaluating exponential and logarithm functions and how we can change forms between exponential and logarithm functions. I've talked about how closely related logarithms and exponential functions are, and we're going to see that a little bit more today. So by the end of this lesson, I hope that you're able to evaluate exponential and logarithmic functions and change forms between exponential and logarithmic functions. So first of all, this part is pretty straightforward. If I give you a function, f of x equals 3 to the 3x plus 1 power plus 1, and I say find f of 0, that basically means plug 0 in for x and evaluate. That's what we're going to do. So f of 0 is equal to 3 to the 3 times 0 plus 1 power plus 1. Well, 3 to the 3 times 0 plus 1 power, that's 3 times 0 is 0, plus 1 is 1. 3 to the first power plus 1 is just 3 plus 1, which is 4. So evaluating that function, that would be 4. Now for this one, if I'm trying to evaluate this function when x is negative 2, I'm just going to plug that right in. 2 to the negative 2 plus 3 power minus 1 is equal to 2 to the 1 power minus 1. 2 minus 1 is 1. So evaluating exponential functions is just plugging in a certain x value. We did this at the beginning of this unit when we were plotting points on an exponential and logarithmic graph. So we followed that same pattern. So, can we evaluate logarithm functions? We've talked about that in your calculator. If you look over on the left-hand side, there's a log button. Your calculator automatically does a log base 10. So if I have log base 10 of x minus 4, and I want to evaluate the function when x is 12, I'd take log base 10 of 12 minus 4. Or, in other words, log base 10 of 8. And log base 10 of 8 would be 0.903. That would be my answer. But what about something like this? What about log base 3 of 14? I can't type that in my calculator. My calculator only does log base 10. So what would I do here? So if I am asked to find the value of a logarithm with a base other than 10, which is the base our calculator uses, I can use the following formula to evaluate the logarithm. So say I'm just going to put in some letters for numbers here. If I have log base a of b, then I can take in my calculator log of b divided by log of a. And that will get me my answer. So this is called the change of base formula. If I have a base that my calculator can't compute, like log base a of b, I take log of b divided by log of a. So here if I have log base 3 of 14, I'm going to take log of 14 divided by log of 3. And log of 14 divided by log of 3 is 2.402. So that's how I would evaluate that logarithm, by changing the base. So let's do a couple of these. So log base 2 of 512 would be equal to the log of 512 divided by the log of 2. Log base 4 of 18 would be the log of 18 divided by the log of 4. Log of 150, when I don't specify a base, it is assumed that it is just base 10. So log of 150, I can just type straight into my calculator. So let's compute each of these. Log of 512 divided by log of 2, that is equal to 9. Log of 18 divided by log of 4, that's equal to 2.085. And log of 150 is 2.176. You can check those in your calculator and confirm that for yourself. So, I want to take a look at this one right here. Log base 2 of 512 is equal to 9. And a lot of you have probably been asking the question, okay, like, so what? Why do we deal with logarithms? What do logarithms help us do? So we've talked about a little bit about exponential equations, some of the different exponential equations you might see in a real-world scenario. We've talked about like if you were investing money or if you had a mortgage. We talked about interest rates and how exponential functions are used there. So how do logs come into play? What do logs help us to do? What I want you to do, just to confirm something, I have log base 2 of 512 is equal to 9. I want you in your calculator to take 2 to the 9th power and see what you get. If you need to pause this video, if you need to take a second to do that, 2 to the 9th power, what do you get? You notice here, 2 to the 9th power is 512. This base of 2 to the 9th power is 512. So basically, what a logarithm is doing, it's saying if I have the base of an exponential function that's 2, and the answer is 512, what exponent do I need to put on 2 to get 512? That's what a logarithm is doing. So log base 2 of 512 equals 9 can be rewritten as 2 to the 9th power is equal to 512. And that's what we're going to be talking about next. So because exponential and logarithm functions are inverses of each other, they can be very handy undoing each other. We can write exponential expressions as logarithms and vice versa. We can write logarithms as exponential expressions. Let's take a look at this to confirm. So I have this conversion for you so you can kind of remember. But I just said on the previous slide, I said if I have a log base b of y equals x, that's basically telling me what exponent do I need to put on b to get y. And this is that exponent. So here's my exponent, here's the base, and here's my result. So notice b, here's my base, x is my exponent, here is my result. So those are just two different ways of writing the same thing. So take a look at this, keep this in your brain as we rewrite these expressions. So 16 equals 2 to the 4th power. This is my base, this is the result, and this is my exponent. So log base 2 of 16 is equal to 4, which is saying the exponent that I need to put on this base to get 16 is 4. So the base of the exponent goes in the base of the log, and then the exponent goes as the answer. Here, 1,000 is equal to 10 to the 3rd. I would rewrite that as log base 10 of 1,000 is equal to 3, which says the exponent I'd put on this base to get 1,000 is 3. So these two expressions right here are the same. These two expressions are the same. They are just opposites of each other. 64 equals 2 to the x. So this is an example of an actual exponential expression where I don't know what x is. I could guess and determine what the exponent on 2 would need to be to give me 64, but I can use a logarithm, rewrite this expression to solve that. So log base 2 of 64 is equal to x. What base, or with this base, what is the exponent that I need to get 64? So those two are equivalent expressions. 64 is equal to 2 to the x, and log base 2 of 64. And using what we just learned about the change of base formula, I could now solve for x. Now let's go backwards. Let's change logarithms to exponential functions. So log base 2 of 32 is saying the exponent that is on this base to make 32 is 5. So I have this base, this is the exponent, and then my result is 32. 2 to the 5th power is 32. Here I have log base 10 of 100 is equal to 2. So the base is 10, the answer is 2, or the exponent is 2. 10 to the 2 power gives me 100. So base, exponent, result. Base, exponent, result. Base, exponent, result. Base, exponent, result. So then in a situation like this, when I have log base 2 of x equals 3, how do I solve for x? Well, I convert that to an exponent, because when I convert that to exponential form, I get 2 to the 3rd is equal to x. And that, as far as solving for x, is way easier to do when it's in exponent form, in this case, than it is in logarithm form. So that's how we change between exponent form and logarithm form. So we're not going to go there, But as you remember the objectives for this lesson, I wanted you to be able to evaluate exponential functions and logarithmic functions, and I wanted you to be able to change forms between exponential form and logarithmic form, which we have done here. So I hope that that video was helpful, and I hope that you enjoyed it as much as I did.